All right, guys, so I'm on page 641, and it's lesson 12.1. Like I said, if you did a lesson a day starting last Monday, the first school day we had to start all of this, you would have done this that day. But again, if you haven't done this yet, here's your chance. If you have done it already and you want to check your answers, this is a great opportunity to do so. I do apologize. The camera's going to be a little shaky. I ordered a tripod off Amazon, so that should be coming in a couple of days. But until then, you get to be stuck with me holding the camera. So just kind of bear with me. I'm doing the best that I can here at home. I know you guys are too, so we're in this together. All right, so this lesson is called Measurement Benchmarks. The last time we talked about benchmarks, we talked about benchmark fractions. Now, we would talk about benchmark fractions like this. Do you remember how when we would compare fractions, we would use 0, 1 half, and 1. And we would take, if I gave you like the fraction 3/4, and I told you to compare it and figure out where it goes on this number line, you would always compare it to 1/2. And we knew that half of 4 is 2, so 3 would be bigger than that, so 3/4 would go over here somewhere. Now, the 0, the 1/2, and the 1 are what we called benchmark fractions. And basically it's just like a checkpoint. The benchmarks are really just there for us to compare with. They're not always exact measurements because they're really just there for us to compare quickly. It's kind of like estimating with pictures. I know how much you guys love to estimate, but estimating is something that's a really important skill when it comes to measurement. The reason I chose measurement lessons to send home with you is because I feel like this is something that your families use on a regular basis. So I feel like this would be the best thing for them to help you with at home. So hopefully I can help you through the video, but hopefully you've gotten some work done at home too. But anyway, these benchmarks, like I said, are just kind of things for us to compare to. When we were comparing 3/4, we would just compare to see, okay, is it bigger or smaller than 1/2? And then we can kind of compare how close it is to 1/2 compared to that. Well, measurement's got its own benchmarks that we can use. Measurement's kind of a funky thing because it's got two different systems that we actually use here in America. We have what's called the customary units. Customary units involve inches, feet, yards, miles. It also involves cups, pints, quarts, half gallons, gallons, ounces, pounds, tons. All of those go with the customary system. Actually, the United States is one of the only countries that still uses this customary system. I'm not sure what the other two countries are, but I think there's only like 3 in the whole world that use them. The other system that we do use in the United States, mostly scientists use it here in the United States, but you do see it from place to place. If your family is from another country, odds are pretty good you're more familiar with this system. This is called the metric system. And it's actually a pretty cool system, but it says like place value. The metric system is based on multiples of 10. Each unit is 10 times as large as the smaller unit. So back when we talked about place value, we would talk about how, a 1 in the tens place is 10 times bigger than the 1 in the ones place. Metric system works very, very similar to that. Each unit you go up, it's 10 times bigger than the unit that's smaller than it. So that one uses things like millimeter, centimeter, meters, kilometers, liters, milliliters, grams. All of those things fall into the metric system. So this lesson actually kind of gives you like some everyday objects that you can use to estimate what the length or the width or the volume or different things like that of, just kind of based on like quick things in your head. This is actually something I use a lot when I'm estimating measurements. I don't always bust out a ruler and measure something. I kind of just use my best judgment based on some of these benchmarks here, which is pretty cool. So let's do this first problem together. Like this is exactly what we would do on the board together. I would just pull it up on the smart board. Maybe this will be better because my smart board doesn't always work. So sometimes this might be better. So it says Jake says the length of his bike is about 4 yards. Use the benchmark units below to determine if Jake's statement is reasonable. So a couple things you could use to kind of estimate some of these things would be for about an inch. It's about your finger. Oh, where's the camera? There it is. So about your, from the tip of your finger to your first knuckle is about an inch. Since you guys have smaller hands, it might be to like the tip of your finger to your second knuckle. Here's a ruler. Sorry, it's a clear ruler. It's a little hard to see. But as you can see on me, sorry, I'm a little, sorry. All right, as you can see, that's about 1 inch on me. The tip of my finger to my first knuckle is about 1 inch. Like I said, you guys, you might have to get out a ruler and see how much it is compared to you, but that's something you can use to represent about an inch. And then 1 foot is about the size of a license plate. That's a whole ruler. My ruler actually has customary units on it, which are the inches at the top. And it's got metric units on the other side of it, which is the centimeters and millimeters, which are the tiny little ones. So just make sure if it asks you to measure with customary units that you use the inches on this side. This one actually says 1 inch on it. And then if it says use the metric system, you can come over here where it says 1 cm. That's 1 centimeter. So that you'd use that side. To estimate about a yard would be about the size of a baseball bat. I kind of like think of it as like the length of my arm from the tip of my finger all the way up to my shoulder is about 1 yard, maybe a little bit smaller than that. And then the last one, this one's kind of a weird one. It says 1 mile is about 20 minutes. So because I can't actually give you an object that's the same length as a mile, what they suggest is think if you were to go outside and walk for about 20 minutes at a steady pace, like around your neighborhood, you probably will have walked about 1 mile. You can also, next time you're in the car with your mom or your dad, you can ask them to check their odometer, which tells you how many miles they've driven, and ask them to tell you when they've gone 1 mile, and they can tell you that. So you can kind of see an estimate of distance that way too. A baseball bat is about 1 yard long. Since Jake's bike is shorter than 4 times the length of the baseball bat, his bike is shorter than 4 yards long. So they give you a little picture of here. Here's Jake's bike, and here's the baseball bat laying next to it. Jake said that his bike was 4 baseball bats long. Well, obviously you can tell from this picture, it's not even close to that. It's about 1 and maybe 1/3 of a baseball bat long. So Jake's statement is not reasonable because it's way too big of an estimate. It was way off. Jake's bike is about 1 to 1.5 baseball bats long. Again, we're not working with exact measurements here. This is all estimating. Example 1 says use the benchmark customary units. What's cool about customary units, and I guess in the metric system too, they have different sets of measurements for different things that you're measuring. So up here you're measuring length, so you'd use how long something is. Down here they would use for volume. It's like how much something can hold. So if you look at a gallon of milk versus a half gallon versus a quart of milk versus a pint of milk versus a cup of milk. What you get at school is right about here. And in the lunch line, it's about, it's somewhere between these two. It might actually be a whole pint. I'm not sure. But that's kind of about what you're used to with milk at school. Your family probably gets the gallon milks, or the half a gallon of milk. But these are all customary units in the customary system, but they measure volume. They measure how much something can hold. Usually it has to do something with liquids. You can do volume of other things too. But with this one, they're showing you it with liquid. And then the last thing you can measure with this, you can also measure weight with it too. You've probably heard something is so many pounds or so many ounces or a ton or something like that. So these kind of give you an idea from there about how much each of these things weigh. So like 1 pencil is about 1 ounce. 1 loaf of bread's about 1 pound. 1 car is about 1 ton. So all of these are different like I said, they're benchmarks. They're not exact. We wouldn't go around measuring, elephants and how many cars does this elephant weigh. No, we would use actually tons, but this gives you an idea. If you know an elephant is 20 tons, then we know that an elephant weighs about 20 cars. So again, estimates. So it says about how much liquid is in a mug of hot chocolate. Now, would you drink a whole gallon of hot chocolate at a time? No. Half a gallon? No. Quart? No. Pint? Maybe. We're getting closer. Probably about 1 cup. So how much liquid is in a mug of hot chocolate? We're going to put about 1 cup. Same thing down here. How much does a grapefruit weigh? Think about a grapefruit. If you're not sure what a grapefruit looks like, it's like a big orange. We know that it's heavier than a pencil, that's for sure. And it's way less than a car. So we'd probably measure it in pounds. So 1 grapefruit's probably about 1 pound. Also, a weird thing about pounds, you might want to put this on your chart. Sometimes you'll see pounds written like this. LBS. That's the abbreviation for pounds. So it's kind of a weird thing because I'm honestly not really sure why it's LBS for when none of those letters appear in that word, but it is what sometimes you'll see. Okay. So turn the page. We're going over to page 642 now. Now we're headed over to the metric system. Now they do the same thing for you. They give you some pictures that kind of estimate what the length and the volume and the mass, which mass is just another word for weight. I'm not sure if you learned about this in science class yet, but you'll learn the differences between mass and weight and volume in science class. But for the purposes of this lesson, it's really just going to be mass is close to weight. Okay, so like I said, with the metric system, each level up is 10 times bigger than the level before it. So the first level that you would work with is a 1 millimeter. And 1 millimeter, it's so tiny. I'm not even sure what that picture is. A millimeter is, let me show you. Woo! Focus, camera, focus. You see how there we go. Those little tiny lines in between each thing? Each one of those little tiny spaces is 1 millimeter. It's super tiny. It's like the width of a grain of rice. It's really tiny. 10 times bigger than that, though, is a centimeter. So let me get the ruler back out. So from the end line all the way up to the 1, the big one, that is 1 centimeter. It's 10 of those little millimeters. So it's 10 times bigger. And that's about the width. Whoops. That's about the width of your finger going across your finger. It's about that size. About a decimeter is the width of your hand. So from your pinky all the way to your thumb is about a decimeter. It's 10 times bigger than a centimeter. And 10 times bigger than a decimeter is 1 meter, which is about the width of your door. So if you go over to your front door right now, from one side of it to the other is about how wide is about a meter. And kilometers is measured in a similar way. They do it the same way as a mile, except for 1 kilometer is about 10 minutes of walking, which tells you if it's 10 minutes of walking and a mile is 20 minutes of walking, a kilometer is a little bit smaller than a mile. So a lot of countries, instead of seeing miles per hour signs, you will see kilometers per hour or something like that, because they measure using the metric system. They don't use the customary system like we do. All right. Is the length of your classroom greater or less than 1 kilometer? So could you walk from one end of my classroom to another in more or less than 10 minutes? Probably take you less than 10 minutes. Our classrooms are pretty small. You could probably walk the whole length of our school in less than 10 minutes. So the length of our classroom is less than 1 kilometer. So fill that one in. And kilometer usually has an abbreviation of km. To measure volume, you use liters. So 1 liter is about about a baby bottle size, maybe a little bigger. And 1 milliliter is like a couple drops from a medicine dropper. So about how much medicine is usually in a medicine bottle? About 120, not 120 liters. You can't fit 120 of these inside one medicine bottle. That's a little crazy. But you can fit 120 of these guys inside one medicine bottle. So it's about 120. Make sure I spell this right. Nope. This is why Miss Smith takes care of your spelling lessons. Okay, and then the last one is mass. Like I said, mass is very similar to weight. So 1 gram. When I was a kid, they always taught us about how this is like 1 paper clip. And a kilogram is like a textbook. So like the weight of your math book. So I'm going to put on here math book and paper clip. Because that's something that's a little easier to, I feel like, use as a benchmark. So about how much is the mass of a paper clip? It's about 1 gram. All right, so let's do some practices with this. So with these, it says use the benchmarks to choose the metric unit you would use to measure each. So reading the directions, this tells us it wants us to use the metric system. So we're going to use these ones over here. Okay, metric system. See how it says metric on each of these? Okay, make sure you're using the correct system. That's really, really important. So then we've got the mass of a strawberry. So I'm using the metric system, so I'm going to come on over here to mass. What do you think I should use to measure the strawberries with? Should I use grams or kilograms? Now, I don't think we'd measure strawberries with baseball bats. That seems kind of crazy. It'd probably be more along the line of grams. And then we've got the length of a cell phone. So we come over here to length. We could measure a cell phone in millimeters, if we wanted to. We'd be there for a million years, but we could do it. We could measure it in centimeters, probably for sure. We could do it in decimeters, although your phone might be a little bit smaller than the width of your hand. My phone is just smaller than that. So once you start getting something that's a little too big, you may want to kind of go back to some of the smaller units. With your phone, I think it's probably best to use the centimeters because that's a little too small. You could, but it's a little too small. This is maybe just a little too big. So I would use the centimeters to go with phones. So length of phone would be measured in centimeters. All right, circle about our estimate. The width of a teacher's desk. Would we measure that in meters or 10 meters or 1 meter? So if we say a meter is about the width of a door, do you think my desk at school is 10 of those doors? Go ahead and go over to your front door and picture putting 10 of them right next to each other. Sounds kind of crazy, doesn't it? That's way too big for a desk. So I would say a better measurement would be 1 meter. I think my desk is probably closer to 2 meters, but it's definitely not 10. The amount of liquid in a punch bowl. Let's go over to liquid with volume. Your choices were 2 liters or 20 liters. And so, yeah, I would say probably 2, maybe 20 liters actually. Because 2 of these are only going to feed 2 people. In a punch bowl, you're going to feed a lot of people. So I would go with 20 liters on that one. Sounds like a lot, but liters are kind of small. Distance between Seattle and San Francisco. Now keep this in mind, Seattle is on, I wish I had a map in front of me. But Seattle is on the left side, or the top left side of the country up in Washington. And San Francisco is on the bottom left side of the country down in California. So 6 miles is probably the width of your neighborhood, maybe. A couple neighborhoods put together, but 680 miles would definitely measure a couple states apart from each other. So that would be that one. This is kind of cool. Which metric unit would you use to measure the distance across the United States? We come back over here to distance. If we started to measure the entire United States using meters, or miles or whatever, we're going to be there forever. I'm not sure why your book wants you to do it in miles now that I look at it, because it said all metric units, but we could do this one. We would do it in miles, or we could also do it in kilometers too. So just depends on which system you use. All right, this section down here says use the benchmarks to choose the customary unit you would use to measure each. So we're switching back to the other system. Okay, so you're going to use this system to come back to over here on the other page. So the length of a football field. So we're going to come over here and we look at length. I would not measure football field in inches. Again, we'd be there forever. Same thing with feet. And a football field is actually smaller than a mile. I know a football field seems really long and a mile seems really long, but that's actually way too big. Football fields are actually measured in yards. So that one would be yards. The weight of a pumpkin. Not length, not volume, weight. Again, a pumpkin's way heavier than an ounce, but it's way less than a ton. So I would use pounds for a pumpkin as well. Now, this is the part I want you to pause the video for a second. I want you to try these two problems on your own. You're still using the customary unit, so you're going to go back to the other page for an example, but I want you to pause the video right here. Okay, now I'm going to show you the answers. Hopefully you've unpaused by now. The weight of a watermelon. Again, pounds is a loaf of bread. Ounces is a pencil. A watermelon's way bigger than 4 pencils. It's probably about 4 loaves of bread. The amount of liquid in a fish tank would be, gallons is like a gallon of milk. And 10 cups would be like a cup, that you would drink out of. You wouldn't put 10 cups in there. Again, that would not hold many fish. A big fish tank would hold probably 10 gallons of water. These ones are kind of fun down here. It says more or less. So Matthew's large dog weighs more or less than 1 ton. Now, have you ever seen a dog that weighs more than a ton? Probably not. So Matthew's large dog weighs less than 1 ton. The amount of liquid a sink can hold is more or less than 1 cup of water. Again, you probably don't have a very good sink if it only holds 1 cup of water, because that's like a cup that you drink out of. So that would be more. A paper clip has the mass of more or less than 1 kilogram. So here's a paper clip. In a kilogram, it's going to be less than for sure. These problems over here, now these are not ones that we would typically do in class, so you can do these ones for fun, just to challenge yourself a little bit too. If you want to do the challenge, you can scan this QR code here. I have noticed that a couple of the QR codes, the videos are usually somebody acting out the problem that it goes with. Sometimes it doesn't line up, like sometimes my smartboard doesn't always line up with the problems in your book. I think that's the company who makes the book. They don't quite have it all lined up. But they give you kind of an idea if you want to use that too. But if you want to challenge yourself, you can do these ones too. Do these ones with your family. I think your family would enjoy doing this with you. These are not ones we would have done in class unless we needed a little bit more of a challenge. Now, I probably would have done this lesson with you way differently in class. We would have done something more fun where we could play around with some of these measurements a little bit. But because we have to do it like this, we just got to do them straight up like this. So I'll go through the answers of these with you real quick. If you want to try them, pause the video. And then once you finish them, you can go over the answers with yourself. It says, Christina is making macaroni and cheese for her family. Would Christina use 1 pound of macaroni or 1 ounce of macaroni? This one is cool because it actually, pounds goes with the customary system, but ounces, well, I guess ounces go with that too. But even if they crossed over systems, like let's say they did pounds and grams, like you could still use the benchmarks to compare with. But this one, if we go back to pounds versus ounces, here's about 1 pound, and here's ounces. Okay, ounces are there's 8 ounces in a cup. If we use only that much macaroni versus that much macaroni, we only have just a little bit of mac and cheese to make, but if she makes it for her whole family, she probably wants to use 1 pound of macaroni and cheese. Yep, she's making it for her family, is what it says. So you would use about 1 pound. She's making it for herself. You can get like those little cups you put in the microwave. That would be about 1 ounce of macaroni. What is the better estimate for the length of a kitchen table? 20 centimeters or 200 centimeters, or 200 centimeters or 20, guys, can't talk. 200 centimeters or 200 meters. There we go. It's just like we were in class. It's like, did you miss me? I'm sure you did, because there's a little bit of Mrs. Spears for you today. So I would say we would use the centimeters for a length of a kitchen table. 200 meters would be like 200 doors laid across side by side, and you know that's way too big. So this would be 200 centimeters would be a better estimate. Jody wants to weigh her cat and measure its standing height. Which 2 units should she use to weigh her cat? I did this one. It doesn't say what system they want you to use, so you can use whatever you want. If you use customary systems to weigh with, I would measure the cat in pounds, and the length with, I would say probably feet or inches. Probably not going to be much longer than a foot or 2, so you might want to use inches. If you use the metric system, I would say you could measure the cat in decimeters or centimeters. You might take you a while, but you can do that. And if you did weight, I would do it with either grams or kilograms would work. The cat may be smaller than a kilogram, and if they are, then you'd want to use grams. But there are a lot of grams. It might be more than a kilogram. It just kind of depends on how big your cat is. Dalton uses benchmarks to estimate that there are more cups than quarts in a gallon. Is Dalton's estimate reasonable? So here's more. He says there should be more quarts than cups in a gallon. His estimate is not reasonable because quarts are bigger than cups, so there would be less quarts in a gallon than there would be cups in a gallon. Like I said, if we were in class today, I would have done an activity where you could see how many of these cups fit into a gallon, and we could play around with that a little bit, but there's videos about that online. You can always look those up if you want to. But each of these fits inside of a gallon. I believe it's 4 quarts to a gallon, and there's way more cups to a gallon. So his estimate is not correct. And the last one, select the correct word to complete the sentence. Justine is thirsty after running 2 miles. She should drink 1 pint, 1 meter, or 10 pounds of water. Now, we don't measure water in pounds. We don't measure water in meters. We measure it by volume, which is pints. So she would drink 1 pint. All right, guys, that's it for me for today. This other page is your normal homework page, so you can use that to practice with. They give you the words over here, but you are always welcome to go back and look at the benchmarks that we've been over here before. Like I said, if you have any questions, leave me a comment, and I will do my best to answer them. Love you guys. Hope you're having a good day. Bye.